Hey guys, so let's talk about like a pretty simple program. Um, so here's the part. So this part, it was facing, OD turning, and milling. Now for the milling, let me see something. This is the drawing. All I had talked to one of the guys over here, and he made a CAD program. And this is going to be programmed to do on X and Z using X and Y coordinates. So as you see, you have an X and Y, and you got 1 point. So as you see over here, let me see. So we got this corner to this corner, from here to the middle of this radius, from here to here, and then I'll show you how to do repeat. Okay. So let me cut this off, and okay, so we have a facing programming, and just to do quick programming with you guys. So you go to the end, arrow, insert, okay. See, when it does this, it thinks you might want to add another line, but we don't. So we go to shape end, or so that might be a little confusing for somebody that started, but technically right now, if you have a shape end, and let's say you're at the end and whatnot, always arrow, and this is all your program complete. This is if you finish program search, calculate, we get to this later, insert, erase, shape copy, unit copy, multiple unit copy, program copy, and 3D assist. So we go with insert, usually get this, and remember the first, second, and third, this is your milling, the fourth is going to be your turning, and this is if you want to do like a M code and G code program. So we go for turning. We go to facing. Okay, so we have a facing. Now it's gonna ask you how much, and like whatever you put in, a lot of times it's gonna ask you finish allowance. How much do you wanna put leave on finish? Depends on the size of the machine. If you work on 250, 3000 is good. If you work on a 350, you can leave 5000 on a Z. So pretty much it's gonna remove whatever you tell her, 15, 20,000 per cut from here, and then at the end it's gonna leave you at 3,000, where you could run it a little bit faster and a little bit slower, give you a nicer surface finish. So let's go 0.003. As you see, this is enter, and we have our finish. Once you press enter, it's gonna give you a rougher and the finish line. Okay, so general out, and it tells you automatically applies tools, but 80 it's okay, but let's say for rougher, for finishing, and you see finish, you're gonna press this. When you press this, you go to tool data window. Okay, I press that, and now it's gonna show me tools in my library that are capable of doing such a task. So we have the 80, and we also have a 35. So I'm gonna pick that 35. I'm gonna press OK. And now I have 80 and 35. Now it's asking you depth 1, okay? If you read over here, it's gonna ask you max depth of cut. So let's call it, let's say 30,000 cut, okay? Let's drag this out here. Now surface speed. So surface speed, 320 surface speed. Okay, then you have a feed rate. Let me see if I can get you the better. Okay, so we have a feed rate out under the FR. Here's a closer look. Okay, feed rate, let's call it 8,000. Okay, so we have 320 speed, feed rate 8,000, and M code, let's put M8, and M8 it's what turns on the coolant. M9, it's what turns off the coolant. Those are the only M8 we're gonna use here. Now we have the finish. So we have a 35. Okay. Surface speed, let's go 420. So a little bit faster. And surface finish, so feed rate, let's feed it 4000, and coolant. When you press this, I press enter 1, 2, and boom. Now it populates another line for us. So we have a, rougher, finish, and now we have a figure. So SPTX. It's calling you, so you go back starting point X. So it's asking you if you're gonna go, so facing comes here. From up, down. It's asking you how big, where do you want me to start? This is a 2-inch material, okay? So let's say I wanna start from 2.1 inches. Go a little bit higher just in case. SPTZ is asking you, starting point Z. Well, how much material you want me to remove from the point you set as your 0? So let's say you want to clean up the part, you can remove 20, 30, depends how much stock do you have. So let's tell her to go and start 40,000 from the 0 you set. Finish point X. Like, where do you want me to go? So this is 2 inches on top. This is 0, center. So you want to go down to 0. Okay? So finish point X, we're going to 0. And final point Z, we also want to go to 0. If, for example, you'd want to leave 5,000 stock extra and maybe get back to it later in a different operation, then you could say, leave 5,000 stock over here. But normally, if this is, you're not gonna go back, go back to, let's say this is a 0. Now, and, so this is the facing, right? Let me see, I'm gonna erase this, I don't need it. Okay, and same thing is for OD turning. You have 2 inches, 30,000, 0, your rougher, your finish, your tools, depth of cut, speeds, and now we're just doing a line with the 35,000 radius. We're cutting it down to 1 inch, 199 1 inch, and 995,070. So pretty much, as you see, it's just a light skim cut. So she came up here, did the chamfer we put in the front, and cut into a material about 5,000 just to clean it up. Okay. Now, when it comes to, I'm gonna erase this, I don't need it. When it comes to the mill, so how I did this, pretty much, so you can go here, and once you press here, and you touch this off, it will show you a solid. Okay. And you can see here, you could make it smaller. Put one finger, move it. You can rotate it. And such. Let me see something. 0.979. I'm gonna mark this. And 1. Beautiful. See, now we have it's gonna do a circle. And what I did was, so technically you have a line left on XC, but when you write program, okay, I needed to use X and C axis, but I gave it an XY input. So XY has to be put, and this will turn yellow. So I gave him all the points, which is, which is line, right here, I started. And then, as you see, you have clockwise, then counterclockwise, counterclockwise, So all the numbers are here. Okay, this is radius you started on. The material is 2 inches, so I had it to start at 2 inches 20. And over here, when you press at the CNR, and it says number of repeats for shape. So we want this to repeat 8 times. So you draw it 1 time, and she will repeat the same shape 8 times. Now, once you have your clockwise, and this is gonna be options. You can do a line, clockwise arc, counterclockwise arc, so rotation, clockwise shift, and this is what we're doing, and counterclockwise shift and different shifts and repeat it. So we clockwise and we're shifting because we're gonna shift 8 times, so technically repeat, line, so this is your geometry, these are your radiuses, so 2-inch diameter, 1-inch radius. So this is 1/2 inch radius, so half of that is 1/4 and 1/4, and at the end you press repeat and that automatically will go back to this one and it will repeat it 8 times. So that's how you come out with this, and I'm gonna run it for you and you see how it works. Okay, here I'm gonna shut off the coolant. Let me see something. Oh, and if you wanna also, you made a program. Let me see something. Scale change 0.5. Part. If you made a program, you can come here on the trace, and you can see how this worked out. If it doesn't look good on the trace, trust me, it's not gonna look good on the actual part. So you're gonna see this is not gonna use a Y. It's only going to use X and C. Okay. And it's gonna pretty much repeat the thing. Now, let me make something. Okay. If, for example, you measure your part, and right now it's using 1/2 inch end mill, it's grinded, and when you look at the geometry right here, it's telling you, I'm telling her that this actual size of the end mill is 485,000. If your part still is not, it didn't cut deep enough, you can tell her, you can make the end mill smaller, and then she's gonna go deeper. If it removed too much material, you make the end mill bigger, so she thinks the end mill is gonna be bigger, so she's not gonna cut as deep because she thinks that, let's say that end mill, for example, it's, you know, it's much bigger than it actually is. So like on your tools, if you go on your tools and you go on my, let's say, 35 finish, the perfect dimension for me, I have to bring it down on offset X 2000 below 0. That gives me a perfect. So just like when you offset, when you add, you could, you know, go on the plus or minus, right? It's gonna raise or lower the actual tool. The way you offset your end mills is by making your end mills larger or smaller. So once again, if these holes and I measure them, and these are supposed to be 1/8 of an inch. If I measure diameter from here to here, and it's, let's say, supposed to be a quarter lower than 2 inches, so it should be 1 inch and 750. If it would be 1 inch and 755, that means it's still not cutting deep enough. So I would go here, and then I would change it to 480. So now the machine will think that the end mill is smaller, and it's gonna compensate and cut in deeper. If it cut it too deep, then I go and I'm gonna make this, let's say, 490. Then the machine is gonna think that the end mill is much bigger, so she's gonna give you a little bit more room. And this is how you pretty much can control cutting dimensions for the end mill. So pretty much this is gonna be it for today, guys. You know, these are pretty basic things to kind of learn. And like I said, if you probably ran a Mazak for a while, it's gonna be it's gonna be easy for you. But for somebody that started or even never worked on a Smooth G, it's kind of, I'm hoping it's gonna be, find some benefit for you. Now, the first unit and the second unit are great. Only this one, as you see, is in a color because I I shut these off so they don't interfere with the milling program. But you can go here and let me see, here and here you do multiple control out, and then you could see over here I have marked these two, shut them off. So I demark them. You go to apply. You can shut this off, and now if you go to toolpath and you do part, now you see this whole part is drawn. Your axis, you can change your plane. So XZ is gonna be more for your lathe. Plane changes, you can do X and Y. You have two planes now. This is for lathe and this is for your mills. Alright guys, thank you for watching.